Okay, welcome everybody. Thanks for joining the Fall 2019 Short Talks VideoCon session for the Midwest Space Grant region. Our first presenter will be Matthew Nelson from Iowa State. Take it away, Matthew.
Okay. Do I have control?
I think you can take control. Just go to the share at the bottom of your screen.
There we go. Okay. Hopefully everyone can see that, or at least see it so far.
You can see that. Thank you.
Okay, great. Okay, so I'm going to talk about a lot of the stuff. So I guess a brief introduction on myself. As James said, my name is Matthew Nelson. I'm the Assistant Director for Iowa Space Grant Consortium. I'm also the Director for a program that we have here called Make to Innovate. And a lot of the research that I do is actually in engineering education. So this is going to be kind of tied to what we do and some pedagogies that we use, especially with this program. So I'll do a very brief kind of introduction to history, talk a little bit about the curriculum that we use for that, how we implement this program, a few things with results. I won't talk about anything with future work. I'll talk about a little bit of some lessons learned, and I'll try to keep this, James wanted to keep things within the 15-minute window and hopefully have some time for any questions or anything as well. So the Make to Innovate program that we have, it began in the fall of 2011. We started off with about 80 to 90 students. We're now at around 200 students. We started this as a way to give students more hands-on experience. When we started this back in 2011, we knew we wanted to do hands-on. We didn't really go a whole lot into the pedagogy with it. Over time, of course, we've continuously assessed and we've kind of steered things more so that we're lining up with certain learning outcomes with this program as well too. It was also a way that we kind of consolidated several groups. So for those of you that might remember, we used to have another lab called the SSCL. That's where a lot of our projects like the high altitude ballooning and rocket projects were being done at. And we had a few other projects, and so we kind of decided to also consolidate a lot of these under sort of one umbrella that we could use for that. Again, we've now matured the program to educate students on solving real-world problems and learning both hard and soft skills with that as well. This is just a basic graph just to kind of show some of the growth that we've had. We've had some pretty crazy growth from time to time. Again, we started relatively small. We peaked at almost about 300 students one semester. We kind of then did some things to kind of rein that back in a little bit. And again, we're sitting about 200 or so now. And some of this is probably due to the Iowa State University has had record enrollment numbers as well too. So some of these probably are contributed to that. So the philosophy that we have with this, we want to reinforce our students' understanding of engineering fundamentals. We want to use this to engage students with both faculty and industry experts. And as I'll talk about, we have a lot of industry folks that work with it, and we do have faculty advisors that work with all the various projects as well too. And another thing that we want to do with this program, and this helps even address some things like with ABET as well too, is adding some additional skills besides just the engineering skills, and these are professional development or soft skills such as teamwork, leadership, communication, and even ethics within that as well too. So we do have a variety of projects within the program. Again, as we do a lot of stuff with rocketry, we have a number of unmanned aerial systems or drones that we have with that. We've done a Mars rover, which you can see there in the top picture. Of course, we still do a lot with our high altitude balloon program that we have here. And we've been doing SciSat, which is our CubeSat program. And that actually should be hopefully launching here on NG14 this upcoming, next about a year from now for that. We kind of divide our projects up to a couple of different categories. We do have some that are being driven through competition. So these would be like our Mars rover, Micro G. We have quite a few that go through NASA type of competitions, big ideas. We do have some that are tied to research. So again, all the projects are required to have faculty advisors, but for some, we're also doing some that are related to some of their research areas. Cardinal Flight's drone. Eagle Eye is a Martian vehicle. So it's actually designed to possibly fly in Mars. We've done a lot of stuff with improving some of our wind tunnel capabilities as well. We have some that we kind of consider to be service, or those that can be used for things either on campus or even outside of campus, or we've done collaboration with. Our high altitude balloon program is currently doing collaboration with our sister university at University of Iowa. SciSat and Jarvis is another drone that's working with another class to have them do the drone flights. And then in big thing to do, Boeing is a big partner that we have. So is Collins Aerospace. So we have a few projects that are being driven directly from them. So we have one that's working on some new technologies that could be applied to like electric flight, and we have another one that's doing stuff with their manufacturing floor and working with Collins on some ADS-B technology improvements as well too. So a little bit about the curriculum and how we approach this. We have two classes for this. We have the 294 and the 494. Actually, this updated. The 294 is no longer an experimental. That's what the X means. And 495 will no longer be experimental as of next. And all it means is that, originally these were experimental courses, and now they'll be permanently added to our curriculum. The freshman, the 1-credit class, and it's restricted to freshmen and sophomore. The 400 level class is for juniors and seniors. There's 2 credits for most students unless they're in leadership position, either project lead or team lead, and then it has to be 3 credits. That means that only juniors and seniors are in those leadership positions for that. The 400 level also counts as a technical elective for many of our students as well. So this is very much a flip we have. It is very student-centric, so we don't have a normal class period that we meet. We do have normal checkpoints for that. And so we do meet with this, but it's, time, stuff like that. And again, the reason why we classroom with this is to engage the students into that type of learning process for that. It's very much project-based learning. This is where, with project-based learning, we're having students and analyzing the problem. Project-based learning is sort of extension of based learning, where students look at a problem, but in a project we oftentimes have several problems we need to address for that. But the process is the same. They have to analyze the problem. They have to devise the solution for that. They work on the design. They build that design, and then they test the laboratory that we have for that. We have things such as printing things that they can for that as well too. So this is a team-based learning. It's all organized around how they're looking at the problems and their own project, and it's very interdisciplinary for that reason as well too. So we're in aerospace engineering, but we do actually include a lot of students from ME, electrical and engineering, software engineering, computer science. We do also, and we've been pulling in more students from College of Business, Design College, and other departments as well into the program. So again, very project-based learning, hands-on approach with that. We have the student by doing under the of faculty and technical advisors that we have for that. There's where students are experimenting, so kind of learn through that experimentation process. And again, a lot of leadership into it as well for that. Just kind of down on how we rating. faculty it does contribute to the grade. We do the report that they met, and that's where we're kind of keeping track of where we're at. We do design reviews. We also have some milestones and checkpoints that we do. Since it's a flipped classroom, it's very easy to say, I'm not going to show up, and we've had that earlier versions of the program. Since then, we do take attendance mechanism that we use that. And another key to do is cross-evaluation. So students do evaluate each other, and then we use that in composite, and we can also use for feedback to the students as well. Things on how we do the implementation with this. So we use Canvas. Canvas is the learning management system that we use at Iowa State. A lot of our assignments are through there. We actually use Jira. We got a license, free copy of Jira. It's a project management, a very powerful management suite. So students are given a lot of ability to set up their tasks, generate Gantt, work breakdown structures, and also use it to kind of keep track of their time tracking. It gives us a check to see that students actually engaged in part of the process. We have a house attendance system called ATRACS. It's a student's ID card. In the last about 3 years, and CATME does all of our cross evaluations and helps with our team assignment. This in-depth analysis does some other psychological analysis as well too. So we can, again, see any kind of issue might be coming up with that. We do those twice a semester, midterm and at the end as well for that. The way that we implement this, all the projects, each project usually between 2 to 4 teams. Each team has no more than 6 students. For a project, can have multiple teams. It can be divided up either by discipline, maybe a electrical team or a mechanical team, maybe by a function. So this team is going to work on the wing, this team is going to work on the fuselage type of thing as well too. We do give some students some latitude on how we can implement, and all that's submitted at the beginning of the semester orders that they have. We have project managers. These students that oversee the overall for that, and they are also our main point of contact. We have team leaders, so within that, again, for each team that's there, there'll be a team lead for that as well too. And of course, the faculty and technical advisors. So each project has a faculty advisor, and usually anywhere between 1 to 2 technical advisors. Our technical advisors are those that from industry. So this is where, again, bring people from Boeing, Collins Aerospace, NASA groups as well too will come in, and we'll also meet with the student on a regular basis to give them feedback on a continuous basis for that. This is just a typical schedule for us. We have kickoff meetings at the beginning to get the students to projects. They submit their charter, basically their statement of work. We do a midterm design review, we do a student poster, and a final presentation for that. One of the big things I get asked a lot, where does our funding come from? Boeing, again, is a huge sponsor. Collins Aerospace is another sponsor. And then Iowa Space Grant Consortium through the student hands-on funding that we have through that. So each project can submit a proposal for that. It goes through the same process as everybody else. And we do usually get at least a couple that get approved for funding through Space Grant. The facilities and, of course, the staff support that we have from that come from the Aerospace Engineering Department. This is just a few things, some results that we've gotten from some of the feedback and surveys that we've sent out to the students. You know, again, overall, we have a very positive response from the students. They enjoy working on these projects. A lot of times this has helped students to get into co-ops or even jobs. And we a lot of times have students that come back, alumni, that either want to also help out with the process as well too. So it's been overall a very positive experience for us. A few things that we've learned, definitely using your tools to your advantage, especially when you have a large classroom like this where you have 200, 250 students. The tools that we use like CATME and Canvas and Jira all really help doing that. Otherwise, we'd probably go insane. We do keep a very open door policy. We're always looking for feedback from our students on how we can improve things, and that goes with the assessment. And we assess the students, but in a lot of ways they assess us as well. And we try to continuously assess things and make, fine-tune adjustments as we go along with the program. Questions?
So thank you, Matthew. That was interesting. I do have a question. This is James. Although somehow I can't see myself on the screen anymore. Remind me, how does this fit into your major? As in, is this a requirement of the major? Every student has to do this? It's completely elective?
It is technical elective, so it is not required at this point. We have had some discussions about maybe using some of this as a prereq, possibly even as a prereq into capstone, but at this point it's not, and we're probably going to keep it that way probably for a while. But it does, for aerospace, students need to, it's up to 12 credits for technical elective right now anyways, 4 courses. And so this definitely helps them to satisfy that technical elective requirement.
Okay, thanks. Are there any other questions?
Matt, this is Jay, and
yeah,
I wondered if you would like to maybe talk a little bit about the challenges you've had with traditional faculty and their perceptions of the class and how you countered that. I know you worked hard around that.
Yeah, so about...
Be nice, Matthew, be nice.
So about a year ago, I was kind of put in front of the faculty, and I think some of it was there's a few misconceptions that was going on. Anytime you have a very different type of way of approaching on how you're teaching stuff, a lot of things that you sometimes get put under scrutiny for that. And I think that's fair. I think it's good that we always ask ourselves, is this still meeting the needs and stuff like that. I think one of the things that I did to help prepare for this, and actually some of even these slides were derived from some of those slides, is, again, we've done a lot of research into this. We've looked into things like project-based learning. We looked into flipped classrooms. When I actually presented stuff to the faculty, I was citing a number of papers that show this. We do know there are some other programs or a few similar programs that are used at other comparable universities as well too, and all of that helped to kind of instigate the validity of it. The other thing is, I think it's just the fact that we just don't simply let the students go out and do the project and say, good luck. Again, we do have a pretty rigorous assessment plan, and we do stick to that assessment plan as well too. And trust me, we get a lot of feedback from students saying, well, why do I have to do weekly reports and blah, blah, blah. And we tell them, initially, it's like, you're going to see this in industry. It's also because it's a CYA for us, because we're showing that, yeah, we are continuously trying to evaluate the students. We just don't let them cut them loose and then say, good luck. We try to be part of the learning process. And that's sometimes hard to do in a flipped classroom. It's sometimes what happens with people is that they think flipped classroom, okay, the students are doing the work, I just sit back and sip my coffee. And actually, you're still very much engaged. It's just, you're just not lecturing. It's more of a dialogue process that you have with the students. I think it's a better way to teach. I'm going to use that term very loosely, because I think there's a lot of different ways you can teach, but that's just my own personal preference as well too. So.
Okay, thanks again, Matthew. I think we should move on, but I appreciate your time, and anybody who has more questions for Matthew can get a hold of him directly.